Okay, so we are learning. I'm recording, guys. So we are recording and learning about surface area today. Surface area of prisms, and cylinders. Okay, so I just did this one, but first of all, lateral area, which is the sides, is going to be the form is lateral area of the sides. Thank you, Katie. It's the perimeter of the base, and I found that the perimeter of the base turned out to be 30 times the height, which is 4. So I just went 30 times 4. I got 120. Okay. Total surface area. I got to add in the top and the bottom, the two bases. So it's 2 times the base plus the perimeter times the height. I came up with 192. Okay. Now, what about this thing? How do we do this one? Same way. First of all, lateral area. Let's check out our notes. So the reading says lateral area is perimeter times height. So I'm going to write that down. Lateral area is equal to perimeter of the base times the height. So what I'm going to do is on the side, I'm going to redraw my base. So my base is this regular hexagon. So I'm going to redraw that over here so I can do a little bit of work with it, okay? Not a perfect drawing, but it doesn't have to be, okay? So this is 4. It's going to be 4 all the way around, okay? So the perimeter is easy. The perimeter of this is 4 times 6, right? 4 plus 4 plus 4 plus 4, or 24, okay? That is definitely the perimeter of the base. Now the height of the thing, the height is 10. So the lateral area, which just is the area of the rectangles all the way, if you're going to unwrap it, it's just the rectangles all the way around. So my lateral area is going to be the perimeter, which is 24, times my height, which is 10, right? My perimeter, which is 24, times my height of the box, height of the prism, which is 10, which gives me 240, and that's in terms of centimeters squared because it's area. Okay, there's my lateral area. Now, if I want to find the total surface area, I'll look at my notes for my formula. And my notes in my formula say it's going to be 2b plus pH. 2b plus pH. Okay, now B stands for the area of the base. All right, well, I've got to find the area of this darn thing. Luckily for me, I happen to know how to find the area of a hexagon. The nice thing about a hexagon is it's broken up into exactly 6 perfect equilateral triangles. It really is, okay? And the neat thing about it is they're all 60, 60, 60. And I know the area of a triangle, so if I go ahead and just do this right here, okay? So I found the area of this triangle, which I can do. I know if this tiny little triangle here, this is a 2, I know this side is a 2 squared is a 3. Oh, let me superimpose that over here for you, okay? Let me take this little triangle over here, okay? So way over here on the side, this tiny little triangle I just drew, draw it much bigger. 2, because I took half of my 4, right? And I know it's a 30, 60, 90 triangle, and a hexagon, that works that way. Break them all up into perfect triangles. So then this height has to be 2 squared is 3, and hopefully everybody knows where I got that, right? Right, up there. So then if I want to find the area of a triangle, well, go back to this. If I want to find the area of this, I find the area of one of these triangles and multiply by 6, okay? Find the area of this triangle, right? So how do I find the area of a triangle? How do I find the area of a triangle? Yeah, it's just base times height divided by 2. So I'm going to go 4 times my 2 squared is 3 divided by 2. But I have 6 of these, right? You guys agree? I've got 1, 2, 3, 4, 5, 6 of these triangles, so I'm going to multiply this whole thing by 6. How am I doing? Well, the 2, let's see, that's going to be an 8. These 2 can just cancel, can't they? So I'm going to get 24 squared to 3 for the area of the base. You okay with me canceling the 2's there and there? Do some simple math. And if you want to use a calculator and get a calculator answer, that's okay with me. So, surface area, you ready? This is the area of the base. That's right there. That's the area. That top and that bottom is going to be 24 squared to 3. That's the area of that. So, the top and the bottom, I've got 2 of them. The surface area is going to be the 2, because I got the top and the bottom, times my 24 squared to 3, plus all the sides, because I want the total surface area, right? Plus all the sides. And I already found out what all the sides were. That was my 240 A beautiful math answer would be something like this. A perfect math answer would be 48 square roots of 3 plus 240. That's a beautiful answer. That's the kind of answer I like. But a practical answer would be more like this, okay? A practical answer that you could actually say, well, I can make that would be my 48 square roots of 3 plus 240, and I get an answer about, 3 or approximately equal to, look at that, bad looking, 323.1 centimeters squared, okay? Which answer do you like, the beautiful answer or the practical answer? The practical answer. I'll take either one, doesn't matter, okay? All right, guys, ready to turn the page? Boom. Oh, look at these things. Oh, I'm not much of an artist, am I? Okay. Anyway, so lateral area and surface area of the cylinder. Okay, so lateral area. Let's write that down. And again, I go to my notes. Thanks to Kurt, I have a pretty good formula. So lateral area is 2 pi r, because that's the circumference, right? Times the height. So we're going to put that 2 pi r h. Okay. And the radius of this thing is not 12. The radius is 6. Everybody agree with that? The diameter is 12, but the radius is 6. So I'm going to go lateral area is 2 pi times 6 times the height, which is 10. Okay. Now a beautiful, perfect math answer, which I love, would be a, let's see, 60, 120, right? So the lateral would be 120 pi centimeters squared. I love that answer. It's a nice math answer or a practical answer. You guys want a practical answer? 120 pi or approximately equal to about 377 centimeters squared. I'll take either answer. I really like this answer. So what about the total surface area? Now that means I got to add in the top and the bottom. So if I wanted my total surface area, look at my notes to find out what the formula is. So my notes say, okay, it's 2 pi r h plus 2 pi r squared, because Claire added in the other part of that, so we got our 2 pi r h plus 2 pi r squared. And so my surface area is going to equal 2 pi times 6, because my radius is 6, right? Times h, which is 10. We already did that one though, didn't we? So that we already knew that was 120 pi. Plus 2 pi times my 6 squared. So let's see, that's 120 pi, right? 36, okay, see the 36? 36 times 2 is 72, plus a 72 pi, or 192 pi centimeters squared. That's the beautiful answer. That's a math teacher answer or a practical answer. 192 pi, or about 603.2 centimeters squared. Okay. Now, let's think about this one, huh? Let's think about this one. And I used to have something in here in a box. Let's see what else I have. Oh yeah, here it is. Alright, I'm going to have to dump all this out, but it's going to be worth it. Alright? I like this problem. Let's think. Okay? Let's see a box. I had a box in here somewhere. Let's see a box in here. There's a box.
There's a box right there.
Where, Katie?
Right under the wheel.
Perfect. That'll work. That's my tape box. That'll work. Okay? Okay. Perfect. This will work great. Okay?
Yeah.
Okay, so let's think. If I'm going to paint, okay, I want you to think about painting, all right? So, where's paint going to go?
Surface.
Now think about it. Where's paint? What am I going to paint? So, if I paint the entire box here and did the formula, you ready? This circle right here won't get painted, right? Because it's going to be, right? Does that make sense? Well, I'd paint this, right? So what I'd have to do is do the box, subtract out, this circle, right? And then I'd have to add this circle, right? So let's see if we can do this. So I'm going to think this through, okay? So for the surface area of this thing, what I'm doing is just total surface area I know is going to be, let's see, surface area of this thing would be, first of all, let's see, surface area is my 2 times the base plus pH. Okay, so I'm going to go my 2 times the base plus pH. Okay, but that's the box, or the that's my box or rectangular cylinder. Okay, then I also have the cylinder. Okay, what's the surface area of the cylinder? Well, that's going to be my 2 pi RH plus 2 pi r squared. Okay, plus my, that's going to be my 2 pi r squared plus my 2 pi RH, right? 2 pi RH, right? Now, this is a circle, right? So I'm only going to have one of the cylinders here, right? I'm not going to do both because this doesn't get painted. Guys, can you visualize that? This is not painted. So I'm going to change my formula. Let me get an eraser. Eraser around here somewhere, maybe. So I'm going to change this to 1 pi r squared. Oh, why did I erase that? Because I'm not going to paint. I'm not going to paint this one right here. Does that make sense? So it's not 2 circles, it's only 1, right? And then I got to be careful because if I paint the box, if I paint the entire box, I can't paint this circle because this one's going to be underneath, right? So I need to subtract another circle. Okay, so then let's subtract another circle. So this circle's gone. So here's the formula for this particular figure. It's going to be 2 times the base plus perimeter times the height plus the 2 pi RH, which is kind of weird because you can see a circle here, but this circle gets subtracted out from the circle here that never got painted, right? We want to paint it twice. So, all right, area of the base. Let's figure it out. Big B, which is area of the base. Let's see what that is. That's going to be 9 by 4, so that's 36. You seeing it? So let's get that. 9 by 4 is 36, okay? Plus the perimeter, let's see, 9 plus 4 plus 9 plus 4, that's 18 plus 8. 18 plus 8, what's 18 plus 8? 26, right? 18 plus 8 is 26, so the perimeter is 26. The height of the box is 5, okay? So, I've got 2 times the area of the base. Got that, plus the perimeter times height plus 2 pi. Now the radius of the little cylinder is 2, and the height of the cylinder is 3. All right, that should give me the total surface area of this funny looking figure, okay? All right, let's see what we got here. Finally, let's do it, okay? So 2 times 36 plus 26 times 5 plus 2 times pi times 2 times 3. I got a grand answer of about 239.7 centimeters squared. That made me think. I like it. What do you think? Was that kind of hard? A little bit. But if you look at it one more time and see that if we paint the entire box, this circle here would not be painted. Agreed? So you got to take away a circle, pi r squared. Okay. If you take a look at this cylinder, right? The bottom doesn't get painted. Agree? So you have to take away another circle, right? So then this circle doesn't get counted because this is a circle that got taken away for this, right? And you wind up with just the surface side of the box and just the sides of the cylinder. It's a weird visualization, isn't it? All right, last but not least, okay? So, if the length, width, and height of this prism are doubled, what effects on the surface area will it have? Well, let's see, what's the surface area? If I double it, so the surface area of this thing is going to be, well, it's going to be 2L plus 2W plus times the height, times the height. Okay, and I'll let you write that down and we'll think about that for a second. Plus, right, LW. Okay, write that down. Let's think about what I just did, okay? All right. So my formula for total surface area is, well, perimeter times height. Okay, perimeter times height. So the perimeter of this thing is L plus W, L plus W. The perimeter of this is L plus W plus L plus W, or 2L plus 2W, okay? Times the height, okay? And then the area of the base, oh, forgot a 2 here. I got to put a 2 here, my bad. The area of the base is just L times W, but there's 2 of them, top and bottom, okay? Now, if the length, width, and height of this prism are doubled, if they're all doubled, right, that makes that 2, that makes that 2, and that makes that 2. What's going to happen to the effect of the base, okay? So then, all of a sudden, this whole thing would be, let's see, so my new surface area is going to be 2, 2, so it's really going to be like a 4L plus a 4W times 2 times the height, plus that times that, which is 4 LW, okay? So what do you think? What happened between here and here? It's just going to be twice as big, isn't it? You can see it's twice as big all the way. So it's just twice as big. So that one's going to make you think, isn't it? Okay, so homework, and I need you to draw the pictures. Draw the pictures, show your work, okay? It's just page 684,